Welcome back, and we're going to continue working with arithmetic sequences, and this time though we're going to get a little bit more challenging of examples to work with. Okay, so we want to find the 10th term of this arithmetic sequence. Okay, we're given A1, we're given A30. Well, okay, so 10th term, that's A sub 10. I don't know what that is. Okay, now what do I know about an arithmetic sequence, right? I know that there has to be a common difference, right? But I don't know what it is. I don't know what the 10th term is, but I know that if I look at the first term, which is 12, so this is like n, right? This is the first term, this is n, and this is an. I get 12, and then somewhere down the road I hit, 30, and then I get 128. Okay, well, the question is, well, okay, I don't know, so I know this formula, an is equal to a1 plus n minus 1 times d, right? I don't know d, I don't know n. Well, actually, I do know n. I know n is 10, but I still don't know. But here's what I do know, right? I know a30. Well, a30 would equal a1, which is 12 plus, and then if 30 is n, that means that this is 30 minus 1 times d, and I know that a30 is the same as 128. With this, now I can find d. Okay, so then I have 12 plus 29d is equal to 128. And then I can isolate d. Okay, minus 12 is 116. And if I divide by 29, I just get 4. Oh, that's nice. Okay, this enables me now to say, okay, well, if I want a10, then this should be 12 plus n minus 1, which is 10 minus 1 times 4. So 12 plus 9 times 4. Okay, so that's 12 plus 36 is 48. Okay, so if it doesn't seem completely obvious right away, try manipulating the information that you're given and this explicit formula. Alright, so find the number of terms in this sequence. Okay, so what can I tell you? It is arithmetic, so there should be a common difference, right? If I look, okay, so I subtract 5 between successive terms, and that seems to hold. So I know d is minus 5. I know a1 is 16. And all I know is that an, I don't know what n is, but I know that an is minus 239. Okay, well, again, I have that explicit formula. An is equal to a1 plus n minus 1 times d. Okay, let me just substitute in stuff that I do know. Minus 239 is equal to 16 plus n minus 1, and then d is minus 5. Oh, okay, so now this has n as the only unknown in it. Let's go ahead and solve that. Okay, so I have to subtract 16 minus 255 is equal to minus 5n plus 5, distributing. Okay, so I move the 16 over and then distributed the 5. And now I have to subtract 5, which puts me at minus 260 is equal to minus 5n, and divide by 5, n is going to be 52. Okay, so, and the last thing I'd like to do is just check. So n should be 52. So just keep in mind that we numbered this one as a1. So you could check just by saying, is 239 equal to 16 plus 52 minus 1 times negative 5? And it will work out, but you should just double check it. Okay. One more example, and then I'm going to have you pause and try the next example on your own. So here we have a11 and a25. We want to find the 400th term. Okay, now this one is a little bizarre, because we know A11 is 65, and this would be, if we think about this in terms of formula, this would be A1 plus 11 minus 1 times D, right? Similarly, A25 is 149, which is equal to A1 plus 25 minus 1 times D. Notice how I wrote them just like that? Oh, we could think of it as a system of equations. There is another way to solve it, but effectively what you could set this up as is a system of equations where you have the system as A1 plus 10D is equal to 65 as your first equation, and then your second equation would be A1 plus 24D is equal to 149. And you could solve it like that, okay? The other thing you could do is reason through this logically, okay? Ultimately, what we're looking for is the first term and the common difference. So what you could say is, if you look at A25 minus A11, okay, we can calculate that value. So it'd be 149 minus 65, and you'd get 84, okay? Now between there, from A11 to 25, this would be the same as adding the common difference 14 times from 11 to 25, right? So then all you have to do is take this and split this, and so what you end up with is that 6 is equal to D. You'll get the same exact thing using the system of equations, and actually you'd also be able to get the A1 value, okay? From here, either route that you take, once you find the common difference, you have to find that first term. So that means that you have to do like A11, which is the same as 65, is equal to A1 plus 10 times 6, which is D, and then you get that A1 is 5. Okay, and then with all of this now, we did a lot of sidestepping. We had to go back and find some things. But now that we have our first term and the common difference, you can go back and find that A of 400 would be 5 plus 399 times 6. Okay, and then if you punch this in a calculator like I'm doing right now, you get a big number. You get 2399. Okay. All right, and so just to recap, you could do a system of equations, or you can reason through it logically. If you do it correctly either way, you should get the same answer. In this last example, this is the same example that we started out the first video with. I just want to encourage you to try and get to a equation format, or get to the algebraic representation that we saw. So can you get to that AN version? And so I want you to try getting there, and then also look for A of 45. Okay, try this on your own, refer back to the video if you need, and then resume this video when you're ready to see how my answer compares to your answer. And here's what I got.